Okay, let's give it a shot, guys. Let's look at this piece right here. Again, if we work well these next few days, you won't have to have any work over break. My goal is that on Wednesday next week that we do a review game. And yeah, review game. Go review game. Okay, that'll be a good time for everybody. What? No. We would do the review game to review the the rules of logarithms and stuff. And so when we got back on say after break, then we would be ready to move towards the test. But we probably a week after we get back from break, we'd have a test. So okay, if you take out this sheet, we learned that logarithmic functions, exponential functions have that shape. And if a is less than 1, it has that shape. We even talked about e to the x. We talked about e to the negative x. But I want to show you a couple pieces. Due to just time, we haven't talked about compound interest and continuously compounded interest, which is something we'll get to. But we have gone over this. The basic definition of a logarithm. This is something that you should keep in mind, and that's why I put it on the sheet of paper. I would have this sheet of paper out as you're working through stuff, pretty often. If it says natural logarithm, that means that it's a base of e. We talked about how anything to the 0 power is equal to 1, and a to the first power is equal to a. We talked about how logarithms undo exponents, how they are inverses of each other, and you're just left with x. And the same rules apply for natural logarithms. Today what I want to do is I want to talk about these pieces right here. And these are things that you guys would have learned last year if you're in Algebra 2. If you weren't in Algebra 2 last year, it's 2 years ago that you learned this. And we can do that, okay? So let's do this piece, okay? And the first rule that we learned is the product to sum rule. And it says this. If you have the log base a of a times b, that's equal to the log base a of a plus the log base a of b. That's what we have. I apologize that the printout came in two pieces. I swear I pressed the right button, but it didn't work out, apparently. And this may seem like magic to some people, like why does that work? But remember, logarithms calculate exponents, and so that doesn't make this too uncommon. If we had, say, x to the a times x to the b, that would be equal to x to the a plus b. Remember, when you multiply things with common bases, you simply add the exponents, which is why this happens. So what do you think is going to happen if you divide them? Yeah, so this is log base a of a minus log base b of, log base a of b. And then a power to a power, if you have, say, x to the 4th quantity squared, what do you do with the 2 and the 4? You multiply them. So we take this c and we multiply it out front, log base a of a times c. And that's what I get. So those are the rules that we want to be able to apply in these situations to be able to simplify them. So the first one says use the laws of logarithms to rewrite the expression in a form with no logarithm of a product, quotient, root, or power. So right here we have a power, or we have a product. I don't want a product. Does anybody know how I could rewrite that? Log of 5 plus log of 3. Right? Pretty straightforward. The next one, I have 3 of them. So I can write the log of 3 plus the log of 4 squared plus the log of 5 to the 6th. Now, Jalen brings up a good point. She could square the 4 to get 16, but who really wants to take 5 to the 6th power? That's a little bit ridiculous, isn't it? So I'm going to rewrite it using my exponents. I'm going to rewrite it like this. Log of 3 plus what? 2 log of 4. Our exponent rule says you can take the exponent and move it down in front of the log. plus, what's the last piece? 6 log of 5. Any questions on B? Then C, it's being taken to the third power. I also have 4 over 7. Are the 4 and the 7 being taken to the third power? Yeah, so I can move that 3 out in front right away. So that could be 3 log of 4/7. Now, if I have a fraction, I can divide it up into 2 pieces and write it as subtraction, correct? But it has to be 3 times the entire piece. So the log of 4 minus the log of 7. If you wanted to write it as 3 log of 4 minus 3 log of 7, that would be fine as well. If you wanted to distribute that through, but you don't have to. Any questions on C? I'm going to rewrite D to be the log base 3 of x squared minus 5 to a power. The square root is the 1/2 power. Very good, Nick. What can I do with that 1/2? Write it out front. 1/2 log base 3 of x squared minus 5. Can I break up x squared minus 5? No, you cannot. You can only break it up if it's written as a product, quotient, or power to a power. See the difference? This is written as subtraction, 2 terms, can't break it up. It's done. Let's try some harder ones. People got mad at me second hour when I wrote natural log. They said it looked like a 1n. They wanted me to write it in cursive. Are you going to be that demanding today in high maintenance? Oh boy. Italicized. Oh, wow. All right. Natural log of 2x to the fourth over x minus 2 to the third. I have a number of things going on here. First of all, I have exponents. Do I deal with those first, or do I deal with the quotient first? I deal with the quotient, and here's why. The entire piece is not being taken to a power, but rather the numerator is being taken to a power and the denominator is being taken to a power. So I first have to deal with this quotient piece. So I'm going to write it right like this. The natural log of 2x to the fourth minus the natural log of x minus 2 quantity to the third power. Now I'm able to deal with those individually. Now be very careful. In the first problem, 2x to the fourth, is the 2 being taken to the fourth power or just the x? Just the x. So I can't just write the 4 out in front. I first must break it up as this is the product of 2 things. So I can rewrite this as the natural log of 2 plus the natural log of x to the fourth minus the natural log of x minus 2 to the third power. See how I broke up 2x to the fourth to 2 pieces? Now I have a single base that's being taken to a power. So now I can move my exponents out front. So I have this natural log of 2 plus 4 natural log of x minus 3 natural log of x minus 2. NL? I don't know. I don't know how they came up with ln. I should research that. Maybe you should do it, just extend learning and say, I love math, and so I'm going to. All you guys want is extra credit. Why don't you do it for the joy of learning, Morgan? Or don't you like to learn? You're on YouTube. Congratulations. Samantha, 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 Sammy, 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 Slippy, Slammy, Swammy, Swimmy, Swimmy, Swinny, Swanny, Swinner, Sam. Sam. Yeah, how about the movie Dumb and Dumber, right? He tries to come up with the name. You know, he's got the briefcase. It's like, who's it belong to? Mary Swenson? He says all the names. He comes back to comes back to Swanson, Mary Swanson, which is actually her name. And the guy's like, well, maybe it's on the briefcase. They look at it. The briefcase is Samsonite. Mary Samsonite, duh. Well, Samsonite is a brand of briefcases. So we'll look it up after we finish. We'll show you the clip. Great, great, great movie clip right there. Yeah. Dumb and Dumber is possibly the single funniest movie ever. Tommy Boy is also absolutely hilarious. So, all right, we'll try the next one. I'm going to write this a little bit differently. I'm going to write as the natural log of 4x squared over 2yz, all to what power? 1/3. So now, should I use the quotient piece first or the power first? Power first. So I have 1/3 times the natural logarithm of 4x squared over 2yz. Now notice that you have more powers in here. You also have products, so we're going to have to break this up. But you also have a quotient. What do you want to do first? Power, product, quotient. Which one? Quotient. So I've got 1/3 natural log of 4x squared minus, oh, better multiply everything by 1/3, right? Slap a parenthesis in there. Natural log of 2yz. All right. Right here? Yeah. Factor out a natural log? Doesn't work like that. Doesn't work like that. Unfortunately. If I had the natural log of 4x squared again, I could factor out a natural log of something, but it has to be of the same thing. Okay? Question. Yeah. Um Yeah, you're right. I understand what you're saying. There are ways to do that, but I don't think we're quite ready for that right now. So, all right, let's rewrite this. I'm gonna go ahead and I'm gonna use the product pieces right now. Okay, so I've got 1/3 times parentheses natural log of what? 4 plus the natural log of x squared minus. Now I'm subtracting all of this stuff, right? I'm subtracting this entire natural log of 2yz. So I'm going to put another parenthesis there. How do I separate natural log of 2yz? 2. There we go. What's up? You could write 1/3 in front of every piece here, but because the entire piece is being taken to the 1/3, that's why I brought the 1/3 out in front right away. Oh, okay. Good point. So this transition right here. Now, let's everybody, let's see, make sure we explain this correctly. Um, True or false? The 4 and the x squared are both being taken to the 1/3 power. That is true. True or false? The 4 and the x are being squared. False. Only the x is being squared. So, Whitney, that's why I wrote this as x squared and 4. Because, yes, the 1/3 is still applying to both of them, but the x squared and the 4 are separate pieces. Yeah, you still should. Because that's a product of two pieces. So I can finish this off now. 1/3 times parentheses, the natural log of 4 plus what? 2 natural log of x minus natural log of 2 minus the natural log of y minus the natural log of z. Well, I distributed my minus sign all the way through. What's up? In this situation, I would have been fine with leaving it in parentheses, but you might see something cancel. Like, I almost had something cancel here, right? Like a natural log of x, if another natural log of x would have come up here, I could have combined like terms. Or if you had a natural log of 4 minus a natural log of 4, then those would have gone away, right? So this situation would have been fine to leave it, but I encourage you to distribute that negative through as you might see terms cancel. Okay. Natural log of 4 minus natural log of 2 is not natural log of 2. Well, I'm sorry. I said natural log of 4 minus natural log of 2 by definition is natural log of 4 divided by 2, which is 2. But we're not gonna go that far. No. We'll get to that type of problem here in a second. Okay. So, all right, let's do the opposite. Rewrite it as a single logarithm. So log base 2 of 5 plus log base 2 of 7 would be log base 2 of 5 times 7 is 35. There you go. That's not too bad, right? B, I'm going to rewrite that as 2 times the logarithm base 5 of 3 minus 1/3 log base 5 of 64. Does everybody see how I have a base 5? I'm sorry, does everybody see how I have a 1/3 in front of this log base 5 of 64? That's a divided by 3, so I have a 1/3 right in front there. What should I do with this? What should I do with this 2? I can put it right up there and get 3 squared. What can I do with this 1/3? Put it up there and take 64 to the 1/3 power. So I can rewrite this. What is 3 squared? 9. So I have log base 5 of 9 minus, what's 64 to the 1/3 power? What's the third root of 64? I think the third root of 64 is 4. 4 times 4 is 16, times 4 again is 64. So 4 is the third root. Now, instead of writing a subtraction, how can I write it? Very good. Log base 5 of 9/4. Log base 5 of 9/4. So we rewrote it as a single logarithm. Letter C, you see again I have all these coefficients up front. I could take this 2 and square the 4. I could take this 3 and cube the 2. I take this 1/2 and move it there. So I have the natural log of, what's 4 squared? Minus the natural log of 8 plus the natural log of square root of 2. Now, if they're minus, what can I do with the 8 and the 16? Divide it. So you have the natural log of 2 plus the natural log of the square root of 2. Now, as they're adding, I can write it as the natural log of 2 roots of 2. One more that's a little bit challenging, then the rest are pretty easy. Any questions on C? Okay, D, I have this 3 on the outside. I'm going to deal with that at the very end. I'll cube everything at the end. I'm going to leave this 3 right here, and I'm first going to go 3 times the natural log of, what can you do with the x plus 1 and the x plus 2? Times them together to get x squared plus 3x plus 2. Minus that 2 natural log of y. What can you do with 2 natural log of y? All right, so you got 3 times the natural log of x squared plus 3x plus 2 minus natural log of y squared. If I'm subtracting these, how do I write them? You divide them. So 3 times the natural log of x squared plus 3x plus 2 all over y squared. And then what do I do with the 3? Cube it. So I get natural log of x squared plus 3x plus 2 over y squared, all the third power. Any questions on that? Okay. All right, good job. Let's try some that are a little bit more straightforward, okay? These next ones go by pretty quick for people, so. It says evaluate the expressions. In this part, these are ones that you guys can all think through on your own and come up with exact numbers. But log base 2 is square root of 32. That looks difficult, but how would I rewrite the square root of 32? What can I do with that 1/2? Put it out front. So 1/2 log base 2 of 32. What does log base 2 of 32 mean? What does that mean? Translate that. Log base 2 of 32. 2 to some power is 32. That's what this means. 2 to what power is 32? 5. So this is really 1/2 times 5. Log base 2 of 32 is 5. What's 1/2 of 5? 5 halves are 2.5. That's your answer. Try B. Try B on your own. B should be a nice, easy one. Try B on your own. Go ahead. I'll pause this. Did you get 2? You can write it as 100 divided by 4, which is 25. Log base 25 and 25 means 5 to what power is 25? Well, 5 to the second power is 25. My students didn't like the way I did C during second hour, so I'll do it differently, okay? What can you do with that 4? Sure. So we could rewrite this as 4 times log base 3 of 27. Now 3 to what power is 27? 3. I guess now I see why they didn't like my way. Well, log base 3 of 27 is 3. I multiply it by 4. Here's how I showed them, you guys. Here's what I showed them. Well, similarly, I kind of wrote it like this. 4 times the log base 3. Can you write 27 as a base of 3? 27 would be 3 to what power? Well, I said, log base 3 of 3, that cancels off. You're just left with your 3, because those are inverses. The reason why I did that, because it sets up for this problem here. I can rewrite this, e to the 3 natural log of 5. What can I do with that 3 in front of the natural log? Yep, so, or take it to the power, so e to the natural log of 5 to the third power. What happens if you take e to a natural log? Those are inverses of each other. And so therefore I'm left with 5 to the third, which is 125. Now, you need to have your calculator out if you don't for this last part. But you've learned all the properties about logarithms that you really need to know. Now you're going to learn how to make good use of it. Please interpret for me what this means. What does log base 6 of 14 mean? What does that mean? 6 to some power is 14. Well, 6 to the first power is 12, or 6, right? Sorry. 6 to the first power is 6. 6 to the second power is... So it's got to be somewhere between 1 and 2, right? Because we're getting 14. That's bigger than 6, but it's less than 36. That sheet that I gave you guys earlier, it tells you how to figure out a problem like this. It says if you have a log base b of something, you can change the base and figure it out. Your calculators don't have a log base 6. Your calculators have a log base 10 or a log base e, which is natural log. So here's how you actually do it, okay? You take the log of your new base of the number divided by the log of the new base of the base. So here's how I think of it. You can write this down. Log of number divided by log of base. And you don't have to use log base 10. You can use natural log of the number divided by natural log of the base. Either way, you're going to come up with the right answer. That's how we change bases, because we don't have a 6 on our calculator for a base, so therefore we're able to use a base of 10. So if you look at our previous problem again, it says, 6 to what power is 14? Well, I can figure that out. All I need to do is this. I do the log base 10 of 14 divided by the log base 10 of 6. And you just do it on your calculator. For b, you would do the log base 10 of 2 divided by the log base 10 of 7. And for c, I'm going to write natural log. You can pick either log base 10 or natural log. It doesn't matter. And then you can start figuring out exactly what they are. And so, I'll just do one of them, because once I do one of them, you guys know how to do all the rest. Log of 14 my calculator has to be reset. Something happened. So log of 14 divided by log of 6. And if you do that, you get 1.47. Now it says to write it to 6 decimal places, which you should do. But what that means is if I take 6 to the 1.47 power, I should get 14. And you should write it 6 decimal places so that's accurate. But if you try that, 6 to the 1.47, you notice we come up with a number very close to 14. Now that's a tough problem. If you went and told some of your really smart freshmen or sophomores, hey, 6 to what power is 14? They could guess and check and after a while come up with something. But the fact is, that's pretty tough to do. Your logarithms make it extremely simple. So that's going to be the last part of what you're asked to do. You should write it to 6 decimal places. That will be your assignment. I just can't remember all 6, and I can't have the calculator up and write at the same time, unfortunately. So, the reason why I did the natural log is it doesn't matter which one you use as long as they have the same base. So what's the base of the log here? 10. What's the base here? 10. What's the base here? E. What's the base here? As long as they have the same base, it works out. Watch. If you go natural log of 14 divided by the natural log of 6, you're still going to come up with that 1.47. So the idea is you can change it to whatever base you want. because you made a mistake, and I will come and help you figure it out. All right, here's your assignment. I kept it short, you guys, and we're just doing half of the stuff. 1 through 15 odd, you expand it like we did at first. So this is an expanding problems. And then these set of problems, you make it into one logarithm. So that's what I'm asking you to do. It doesn't take very long. It's good practice. You will be given a lot of time on Monday. I will extend this assignment on Monday to include the other stuff, and you should have some good work time. On Tuesday, we're going to practice a new skill. On Wednesday, we'll have a review day, a review game, and you should go into a break with absolutely no homework. And believe it or not, but after Tuesday, we will be almost all the way through Chapter 4. So we make kind of quick hash of this stuff, which is good, right? So that gives us some time to play around after break, which we need to because we need to go over some other things. So there you go.